All right, once you have your calorimetry data, we're gonna go through and do the math. Remember, our end goal is to figure out what is the specific heat of the metal and then use that to identify the metal. So here's our data. Mass of the calorimeter water is 150 grams. Initial temp of the calorimeter water is 17 degrees Celsius. The final temperature of both the calorimeter water and the metal cube, because they came to the same temperature, they came to an equilibrium, is 27 degrees Celsius. The initial temperature of the metal cube in the boiling water is 100 degrees Celsius, and the mass of the metal cube was 90.8 grams. This is my data. Your data may be different, but your process of doing the calculations will be the same. So first we need to find our change in temp. Remember that change in temp is final minus initial, oops, right there. So if we want to know the change in temp of the calorimeter water, we're going to use the final temp of the calorimeter water minus the initial temp of the calorimeter water, and that gives us a change in temp of a positive 10 degrees Celsius. If we want to find the change in temp of the metal cube, change in temp is again final minus initial. So we're going to use the final temp of the metal cube, which is 27, minus the initial temp of the metal cube is 100 degrees Celsius right there, which gives us 27 minus 100 is negative 73 degrees Celsius. All right, here's all our data. So the first thing we can do is we can figure out how much heat energy the calorimeter water gained. We know the mass of the calorimeter water, we know the change in temp of the calorimeter water, and we know the specific heat of the calorimeter water because it's water. So we can figure out how much heat the calorimeter water gained. So let's plug in our data, our numbers. The mass of the calorimeter water is 150 grams. Change in temp of the calorimeter water is 10 degrees Celsius. Specific heat of the calorimeter water is 4.184 joules per gram degree Celsius. We're figuring out Q, the change in thermal energy. That's the equation we're going to use. So let's plug those in. And then do the math on that. And so the Q of the water is 6276 joules. Now, if the calorimeter water gained that much heat, how much heat did the metal lose? So if the calorimeter water gained heat, where did it get that heat from? Any heat that the calorimeter water gained was transferred from the metal cube. So that means if the water gained this much energy, that means the metal lost that much energy because it gained it from the metal. So that means then the Q of the metal is going to be the same value but negative because it's losing that much heat energy. Now if we know the Q, how much energy the metal lost, we also know the mass of the metal, and we know the change in temp of the metal. We have three pieces of information now that we can use to solve for the C, or the specific heat of the metal. So the Q of the metal, how much heat energy the metal lost. It's right here because it lost it, transferring it to the water. So the Q is negative 6276 joules. The mass, that's the Q of the metal. The mass of the metal is going to be 90.8 grams, and the change in temp of the metal is negative 73 degrees Celsius. So if I plug that in, I'm going to do this in 2 steps so that I don't mess up my calculations. 90.8 times negative 73 gives me a negative 6628.4. Notice that both of these are negative, so our final answer is going to be positive, which makes sense because a specific heat should be positive. All right, now I'm going to do that. 6276 divided by 6628.4 gives us 0.95 joules per gram degree Celsius. So there's our C. That's the number we're ultimately trying to come up with. 0.95 joules per gram degree Celsius. That's the specific heat of the metal based on our experimental data. Now, every different material has a certain specific heat. That number is a property of that material. So if we look up a table that has all the different specific heats of all kinds of different materials, here's a limited list. We could find a list with hundreds of them. We want to look on here and see, is there one that matches? 0.95, or something close to that. Well, that's pretty close to that. If I had my cube here, which I might, nope, not that. I could look at it and say, okay, does it look like aluminum? Does it feel like aluminum? Yep, that makes sense. That our data also would match with aluminum. So cube number 1 must be aluminum.